Okay, so this is a problem asked over email. This is 11.3.59. They're asking us to use a graphing calculator to find the following sum. And, they give us 1/5, 1/10, 1 over 20, all the way up to 160, 1 over 160. And I already started this video and I had to re-record it because my computer started freaking out. So let's go through it. So if we're taking a look at this sum, the first thing we have to identify is, are we talking about a geometric sequence or an arithmetic sequence? They're really the only two that we've talked about. And when I look at, something like this, I think, that's not arithmetic. I'm not adding a common term each time to get up to the next value. And so I'm thinking it's geometric, and the way I'm going to test whether it's geometric or not is I'm going to take a look at the ratio of successive terms. So if I take the 1/10 and I divide it by 1/5, and then I compare that to 1 over 20 divided by 1 over 10, and you keep seeing if you get the same number. And so if we do that here, take the 1/10 divided by 1/5, that's 1/10, and you multiply by the reciprocal here, and you're going to get a half. Same thing here, 1 over 20 divided by 1 over 10. So 1 over 20, flip this thing and multiply, and you also get a half. So that the fact that I'm seeing the successive ratios being the same tells me that this is a geometric sequence. And so I'm looking at geometric sum. Okay, so this is the situation where we have an r equaling half. That's what we just identified here. It's geometric, and here's our sum formula for a geometric sum. And by the way, I can't remember if I said this. I said it on the last video. It asks us to use a graphing calculator, and I don't let you guys use graphing calculators in this class, so you don't need to. We can do this without a graphing calculator, and I'm just going to show you how. Okay, so the pieces of this formula that we need are, we need a sub 1, and a sub 1 is always your first term. So a sub 1 is 1/5. We need r, and we calculated r to be a half. So we have both of those pieces, and then we also need n, and n is the number of terms that we have. Okay, well, it's probably easiest in this problem to simply multiply this out. I mean, not multiply it out, but just write out the sequence, and then we can count it. So this is 1/5, 1/10, 1 over 20, and we're just multiplying each time by a half. So this is 1 over 40 next, and then 1 over 80, and then 1 over 160. So you can see that we're working with 1, 2, 3, 4, 5, 6 different terms. So our n here is 6. Okay, so I have these three things that I'm going to plug into this sum formula. And basically, I'm summing s sub 6 here. Okay, so actually, let me do that on another piece of paper. So s sub 6 here is going to be equal to my a sub 1, which is 1/5, times my 1 minus my r is 1/2, taken to the 6th power here. And then this is all over my 1 minus my r is a half. Okay, so that 1/5 is actually multiplying that whole thing. Okay, so s sub 6 here, if I just walk through this, this is 1/5 times, I need to take care of my exponents first. So this 6 is being applied to both the 1 and the 2. So this becomes 1 minus 1 over 2 to the 6th is, I think, 64. And then in the bottom here, we actually have a half. 1 minus a half is a half. Okay? So we need, let's just get a common denominator in the top. So this is 1/5 times 64 over 64 minus 1 over 64, and we have a half in the bottom. Okay, so that gives us 1/5 times 63 over 64, common denominator, subtract your numerators, and this is all over 1/2. Okay, now we can take this inside here, take the bottom and flip it and make it a multiplication problem. So this becomes 1/5 times 63 over 64 times 2 over 1. Okay, and then this is just a matter of simplifying for us. So 2 goes into 2 once, into 64 32 times. In the top we're left with 63, in the bottom we're left with 5 times 32. So we get 160. And that does simplify further. Did I make any mistakes? Doesn't look like it. So 3 will go in here 21 times, and oh, no, it doesn't. Does it? There's a 9 and a 7. Nope. Okay, so that's it. So here's our answer.